Hey everyone, and welcome to another deep dive. Today we're going to be looking at some of the most exciting science trends of 2024. For this one, we're going to be looking at an awesome article from CAS, the Chemical Abstract Service. They do some really cool stuff.
They always have their fingers on the pulse of what's happening.
So let's jump right in. First up, artificial intelligence, AI. It's been making waves for a while, but even with some setbacks, its role in research and development just keeps growing.
AI is really moving beyond just the hype now. And it's becoming such a powerful tool. Like if you think about predicting protein structure, that used to be a massive, massive undertaking. And now, thanks to projects like DeepMind's AlphaFold, we're really on the verge of being able to predict the structure of almost every protein out there.
That's insane.
It's incredible.
So that's got to be like a total game changer for medicine and all sorts of other fields.
Oh, absolutely.
Yeah.
I mean, especially when you think about drug development, the speed at which we can now discover new medicines.
Especially in the area of therapeutic antibodies.
Exactly. Companies like Rubric Therapeutics, they're using AI to just create life-saving treatments faster than we ever thought possible.
So AI is revolutionizing medicine, but what about sustainability? That's where green chemistry comes in, right? It feels like it's gone from like a trend to like a must-have for any researcher.
Absolutely. And scientists are finding so many incredibly creative ways to make chemistry more sustainable. Like imagine having tools that can actually predict the environmental impact of chemicals and processes before they even happen. It's really like designing for a healthier planet right from the start.
I love that. What about all that plastic waste?
Right.
The article mentioned a staggering 350 million tons a year.
Yeah, well, it's a huge problem. But there are some innovative solutions emerging. Companies like Mitero are using industrial byproducts and biomass waste to create eco-friendly plastic alternatives and that are easier on the wallet as well.
Okay, now on to something we all use every day, batteries.
Yes.
Crucial for a sustainable future. But they rely on some pretty scarce resources, like lithium and cobalt. So what's being done to kind of address that?
Researchers are exploring all sorts of alternative battery chemistries. You've probably heard of lithium iron phosphate batteries or LFPs. They're becoming really popular because they don't need nickel or cobalt. And then there's promising work on batteries using sodium ion and magnesium.
So like much more abundant materials.
Much more abundant and sustainable.
So you're saying the batteries of the future could be completely different from what we use today?
Potentially, yeah.
That's fascinating. The article also mentioned sustainable catalysts. Can you give us a quick breakdown of why those are important?
Sure. So you know how catalysts make chemical reactions happen faster? Well, traditionally, a lot of them use precious metals, which can be expensive and often harmful to the environment to mine.
So the shift is towards using more earth-abundant materials.
Exactly. Things that are easier on the planet.
Makes sense.
And speaking of batteries, we can't forget about recycling.
All right.
The article highlighted a huge increase in research on lithium-ion battery recycling, with tons of new patents being filed.
Wow.
Innovations like solid and non-flammable electrolytes could make batteries not only more sustainable, but also safer.
Yeah, that's a good point. It feels like we're really moving towards a world where resources are used and reused responsibly, which is encouraging. Okay, let's switch gears completely and dive into the world of biomaterials. I'm talking about materials designed to work with biological systems. This is where things get really futuristic, right?
One of the most mind-blowing areas is bioelectronic materials. It's like the merging of electronics and the human body. Neuralink, for example, they're developing a brain-computer interface that could allow you to control devices with your thoughts. It sounds like science fiction, but they actually got FDA approval for human trials last year.
The article also mentioned something called bioresorbable materials. What are those all about?
So imagine an implant that disappears completely after it's done its job, like stitches that dissolve over time.
Oh, okay.
So they can be implanted, do their thing, and then safely break down and be absorbed by the body. No need for another surgery to take them out.
That's incredible. It seems like we're on this path to having implantable devices that are just seamlessly integrated with our bodies. So cool.
And speaking of seamless integration, we can't leave out 3D bioprinting.
Oh, yeah.
They're using bioinks to actually print organs.
I know, right?
It's pretty amazing. Right now, they're mainly using 3D printed organs for research and drug testing. They can create really realistic models of hearts and lungs. But the ultimate goal is to print organs for transplantation.
Which would be revolutionary.
Absolutely.
No more waiting lists for organ transplants.
Hey, guy.
It sounds like bioprinting is getting more sophisticated all the time.
Advancements like volumetric additive manufacturing or VAM are making it possible to create 3D printed organs with incredible detail. It's a really exciting field.
So from AI to sustainable materials to bioprinting, there's a lot to be excited about in the world of science.
Absolutely.
Okay, but let's not forget about space exploration. It's not just about rockets and astronauts anymore.
Well, it's not.
All the research and development that's happening up there has a huge impact on countless other fields.
Absolutely.
The article mentioned the Artemis program, which aims to land the first woman and person of color on the moon by 2025. And then there were so many other missions in the works. NASA's mission to Jupiter's moon, Europa, China's sample return mission from the moon, Japan's mission to one of Mars' moons.
Yeah, it's a golden age of space exploration.
For sure.
And I think what's really cool is how these missions are driving innovation in other areas. Like, take robotics, for instance. We need sophisticated robots to explore space. And those same advancements then benefit robotics here on Earth as well.
Right. And what about keeping astronauts healthy in space? That requires some pretty serious medical technology.
Exactly. Space medicine research is leading to advancements in medical diagnostics, therapeutics, all sorts of areas that then have applications here on Earth.
It's amazing how exploring the cosmos can lead to breakthroughs that benefit us right here at home.
Absolutely.
The article also talked about how space exploration is pushing the boundaries of materials science.
Spacecraft need materials that are lightweight, super durable, able to withstand radiation. And then those same materials can be used in other industries to create all sorts of innovative products.
And with all the data being generated by space missions, it's no surprise that space exploration is also driving advancements in information technology.
We need powerful tools to process and analyze all that data coming from space. And those tools can then be applied to all sorts of other fields as well.
So space exploration isn't just about reaching for the stars. It's about pushing the boundaries of human knowledge and sparking innovation across so many different disciplines.
Absolutely.
I love that. Reaching for the stars to benefit life right here on Earth. Okay, now on to a field that's been generating a lot of buzz. CRISPR, the gene editing technology.
Yes.
It was hailed as Had it really lived up to the hype?
Well, after years of research and a few bumps along the way, it seems like CRISPR is finally starting to deliver on its promise. There have been some huge milestones recently. For example, Intellia Therapeutics, they got FDA clearance for a phase 3 trial of a CRISPR-based drug for Hashiar, which is a rare and previously untreatable disease.
So there's a chance we could actually cure a disease that was once considered incurable.
It's incredible. Vertex and CRISPR Therapeutics, they got approval for the first ever CRISPR gene-edited therapy in the UK for sickle cell disease and beta thalassemia. They're calling it Casgevy.
The first approved CRISPR therapy for humans.
It's a sign that CRISPR is really maturing as a technology and moving from the lab into the real world. And it's not just about gene editing anymore.
The article mentioned it being used for early cancer diagnosis too.
Exactly. CRISPR-based biosensing is showing real promise for detecting cancer in its early stages.
Where a simple urine test could tell you if you have cancer.
It's pretty amazing.
That would be revolutionary.
It would.
Early detection is so crucial.
Absolutely.
It sounds like CRISPR is really starting to live up to its potential.
It is. And speaking of cancer, there are some other exciting new approaches being developed in the fight against this disease.
Yeah, the article focused on something called immuno-oncology. Can you explain what that is?
Sure. So immuno-oncology is all about harnessing the power of your own immune system to fight cancer. It's a rapidly growing field with all sorts of approved products like cytokines, vaccines, antibodies, and checkpoint blockers.
So it's like training your body's natural defenses to target and destroy cancer cells.
Exactly. And they're also doing research into using genetically engineered immune cells, called CAR-T cells, in combination with vaccines to boost the immune response against solid tumors. So it's really about finding new and more effective ways to help your body fight cancer.
And what about personalized cancer therapies? Are those becoming more common?
Absolutely. They're developing therapies that are tailored to your specific tumor, making the treatment much more targeted and effective. The article gave the example of an RNA neoantigen vaccine for pancreatic cancer.
It seems like we're moving towards a future where cancer treatment is much more precise and less of a one-size-fits-all approach.
But of course, there are still challenges. Therapy resistance, figuring out which biomarkers will be effective, and the fact that cancer cells within a tumor can be very different from each other. These are all areas where research is ongoing.
So even though there are hurdles to overcome, it sounds like we're making significant progress. Okay, let's shift gears again and talk about energy. Specifically, how we can move away from fossil fuels. and towards cleaner sources of energy.
Right. This is one of the biggest challenges facing us today. And the article highlighted a multi-pronged approach to decarbonizing energy production. One key area is large-scale energy storage.
Because renewable energy sources like solar and wind, they're intermittent, so we need ways to store the energy they generate for when we need it.
Exactly. And there are all sorts of energy storage technologies under development, both physical, like pumped hydro and compressed air, and chemical, like batteries and hydrogen.
There's so much innovation happening in the energy storage sector. And the government is getting involved too, right?
Yes, the article mentioned government initiatives, like tax credits, and programs to encourage the development of hydrogen as a fuel source.
So it's this combination of technological advancements and government support that's really driving this transition to cleaner energy.
It is.
And what about nuclear power? Is that still part of the conversation?
It is. There's ongoing research into both fission and fusion. Small modular reactors, or SMRs, are being developed for electricity production and even chemical manufacturing.
Wow.
And then, which is often considered the holy grail of clean energy, is also being actively researched, although it comes with its own unique challenges.
Like what makes fusion so challenging?
Well, one of the biggest hurdles is finding materials that can withstand the extreme conditions inside a fusion reactor. We're talking about temperatures hotter than the sun.
Wow.
The article mentioned research into some really advanced materials, like high-entropy alloys and even molten metals.
It's amazing to think about scientists pushing the limits of material science in their quest for fusion power.
It is.
It's inspiring to see so much effort being put into developing cleaner energy solutions. Now let's turn our attention to a field that often doesn't get as much spotlight: neurodegenerative diseases.
Right.
These are diseases like Alzheimer's, Parkinson's, and ALS, which are devastating for those affected and currently have no cure. Is there any hope on the horizon for people affected by these diseases?
There is. While there's still a long way to go, there have been some encouraging discoveries and new understandings that offer a glimmer of hope.
Okay, that's good. So what's the latest in Alzheimer's research?
Well, for the first time in a long time, we have drugs that actually target the underlying cause of Alzheimer's disease, rather than just treating the symptoms. Aducanumab, also known as Aduhelm, was granted accelerated approval by the FDA in 2021, and then lecanemab, or Leqembi, received traditional FDA approval in 2023. They're the first drugs to actually target amyloid plaques in the brain, which are a hallmark of Alzheimer's disease.
That's a big deal.
It is.
It gives hope to millions of people.
It does.
And there have also been some promising developments in Parkinson's disease research. What's new in the world of Parkinson's?
Well, there's a non-invasive device called Exablate Neuro that uses focused ultrasound to treat Parkinson's symptoms.
Oh, wow.
It's a non-pharmaceutical approach to managing the disease, which is a big step forward.
So it's like a high-tech alternative to medication or surgery?
Exactly.
That's incredible.
And there's been another big breakthrough in Parkinson's research. They've validated alpha-synuclein as a biomarker for the disease, which means they can now test for it in spinal fluid.
That's fantastic news. Early diagnosis is so crucial.
It is.
And finally, let's talk about ALS, or amyotrophic lateral sclerosis.
Okay.
This is a devastating disease that affects nerve cells in the brain and spinal cord, leading to muscle weakness and paralysis.
Right.
It's known for having a very poor prognosis. Are there any new treatments in development for ALS?
Well, in recent years, there have been 2 FDA approvals for drugs that can slow the progression of ALS Relyvrio in 2022. And tofersen, also known as Qalsody, in 2023. While these drugs don't cure ALS, they can help people with the disease live longer and with a better quality of life.
What other promising research is happening in the field of ALS?
They're doing a lot of genetic research, trying to understand the underlying causes of ALS. Recently, researchers figured out how mutations in the NEK1 gene contribute to the disease, which could lead to new therapeutic approaches in the future.
That's amazing. It's incredible to hear about all the cutting-edge research happening across so many different areas of science.
It is an exciting time.
What are your overall thoughts on all these emerging trends?
I think it's an incredibly exciting time to be following science. We're seeing breakthroughs in so many areas, from artificial intelligence to green chemistry to biomaterials to space exploration to medicine to energy. It's clear that science is advancing at an unprecedented pace, and the potential benefits for humanity are immense.
It's truly inspiring to see so much innovation and creativity being applied to solving the world's most pressing challenges.
Human ingenuity, collaboration,
Yeah,
and the pursuit of a better future for everyone.
well said. On that note, I think it's time to wrap up this part of our deep dive into the exciting world of emerging science trends.
Okay.
We'll be back soon with more. In the meantime, stay curious, stay informed, and keep those questions coming.
Sometimes it's those small, steady steps forward
Yeah.
that end up making the biggest difference in the long run.
Yeah, I think that's a really good point. It's so easy to get caught up in the hype of, the latest and greatest, but real progress often takes time and persistence.
It does. It takes collaboration and creativity and a willingness to kind of challenge the way we think about things. The scientists working in these fields are truly pushing the limits of what we know. It is.
Speaking of brilliant minds, is there any particular trend that we've talked about that you're especially excited about?
That's a tough one. But if I had to choose, I think I'm most fascinated by the potential of biomaterials.
Oh, yeah.
Just the idea that we can create materials that work seamlessly with the human body, that can repair or even replace damaged tissues. It's mind-blowing.
I know it sounds like science fiction,
It does.
but it's really becoming a reality. We're seeing real progress with bioresorbable implants and 3D bioprinting. The possibilities are endless.
And I think biomaterials have the potential to completely revolutionize medicine.
You're pretty optimistic about the future of biomaterials, then.
I am. But, I'm excited about all the trends we've talked about. It's a remarkable time to be alive and to be witnessing all these incredible scientific advances.
It's so important for all of us to kind of stay informed about these developments, too, even if we're not scientists ourselves.
Okay.
The more we understand about science, the better equipped we are to make decisions about our own lives and about the future of our society.
Absolutely. Science isn't just for scientists, it's for everyone. The more we know about science, the better we're able to navigate this increasingly complex world.
Couldn't agree more. Let's all commit to staying curious, keep learning, and supporting the amazing work that scientists are doing all over the world.
To a brighter future powered by science.
Cheers to that. Moving on from biomaterials, onto something completely different. Let's talk about a field that's been both celebrated and scrutinized. CRISPR. This gene editing technology, it was once considered revolutionary, but has it really lived up to the hype?
Well, after years of research and a few setbacks along the way, it seems like CRISPR is finally starting to deliver on its promise. The article highlighted two major milestones. First, Intellia Therapeutics received FDA clearance for a phase 3 trial of a CRISPR-based drug for ATR, which is a rare and previously incurable disease.
So we might actually be on the verge of curing a disease that was once considered incurable. It's a game changer.
And there's more. Vertex and CRISPR Therapeutics obtained authorization for the first ever CRISPR gene-edited therapy in the UK for sickle cell disease and beta thalassemia. They've named it Casgevy.
Wow. That's a historic moment. The first approved CRISPR therapy for human use.
It is.
That's huge.
It's a sign that CRISPR is really maturing as a technology and moving from the lab to the clinic. And it's not just about gene editing anymore.
Right. The article mentioned it being used for early cancer diagnosis, too.
Exactly. CRISPR-based biosensing is showing a lot of promise for detecting cancer in its early stages.
Wow, imagine a future where you could just take a simple urine test and it could tell you if you had cancer. That'd be revolutionary.
Early detection is so crucial.
Yeah, it is. It sounds like CRISPR is really living up to its potential.
And speaking of cancer, there are some other really exciting approaches emerging in the fight against this disease.
Yeah, the article highlighted something called immuno-oncology. Can you break that down for us?
Sure. So immuno-oncology is all about using the power of your own immune system to fight cancer. It's a rapidly growing field with lots of approved products like cytokines, vaccines, antibodies, and checkpoint blockers.
So you're basically training your body's natural defenses to recognize and attack cancer cells.
Exactly. And scientists are also exploring ways to use genetically engineered immune cells, called CAR-RT cells, in combination with vaccines to boost the immune response against solid tumors.
Wow, so it's really all about leveraging the body's own defenses to fight cancer.
It is.
And what about personalized cancer therapies? Are those becoming more common?
They are. They're developing therapies that are tailored to your specific tumor, which makes treatment more targeted and hopefully more effective. The article mentioned an RNA neoantigen vaccine for pancreatic cancer.
It seems like we're really moving toward a future where cancer treatment is much more precise and personalized.
I agree. But of course, there are still challenges. Therapy resistance, figuring out which biomarkers will be most effective, and the fact that cancer cells within a tumor can be very different from each other, These are all areas where researchers are actively working.
So even though there are hurdles to overcome, it sounds like we're making some significant progress in the fight against cancer.
We are.
Okay, let's shift gears again and talk about energy, specifically the global effort to transition away from fossil fuels and toward cleaner sources of energy.
It's one of the biggest challenges we face. And the article highlighted a multi-pronged approach to decarbonizing energy production. One key area is large-scale energy storage.
Right, because sources like solar and wind energy, they're intermittent, so we need a way to store that energy for when the sun's not shining or the wind's not blowing.
Exactly. And there are all sorts of energy storage technologies being developed, both physical, like pump hydro and compressed air, and chemical, like batteries and hydrogen.
Wow, there's so many different options out there.
Lots of options.
It sounds like there's a lot of innovation happening in the energy storage sector.
There is.
And the government is playing a role in this too, right?
Yeah, they are. The article mentioned tax credits and programs to encourage the development of hydrogen as a fuel source.
So it's this combination of technological advancements and government support that's really driving the transition to cleaner energy.
It is.
That's great to hear. And what about nuclear power? Is that still part of the conversation?
It is. There's ongoing research into both fission and fusion. Small modular reactors, or SMRs, are being developed for electricity production and even chemical manufacturing.
Wow.
And then fusion, which is considered the holy grail of clean energy, is also being actively researched. But it has its own unique set of challenges.
Yeah, like what makes fusion so challenging?
One of the biggest hurdles is finding materials that can withstand the extreme conditions. Inside a fusion reactor,
Right.
we're talking about temperatures hotter than the sun.
Yeah, that's pretty intense.
It is. The article mentioned research into some really advanced materials, like high-entropy alloys and even molten metals.
It's amazing to think about scientists pushing the limits of material science like that in their quest for fusion power. It's inspiring to see so much effort being put into finding cleaner energy solutions. Now let's turn our attention to a field that often gets overshadowed by other scientific advancements. Neurodegenerative diseases. These are diseases like Alzheimer's, Parkinson's, and ALS. They're devastating for those affected and currently have no cure. Is there any hope on the horizon for people with these diseases?
There is. While there's still a long road ahead, there have been some really encouraging discoveries and some new understandings that offer a glimmer of hope.
Okay, that's encouraging to hear. So what's the latest in Alzheimer's research?
Well, for the first time in decades, we actually have drugs that target the underlying cause of Alzheimer's disease, rather than just treating the symptoms. Aducanumab, also known as Aduhelm, received accelerated approval by the FDA in 2021. And then lecanemab, also known as Leqembi, received traditional FDA approval in 2023. They're the first drugs to target amyloid plaques in the brain, which are a hallmark of Alzheimer's disease.
Wow, that's a big deal.
It is.
It gives hope to millions of people. And have there also been some positive developments in Parkinson's research as well?
There have. There's a non-invasive device called Exablate Neuro that uses focused ultrasound to treat Parkinson's symptoms.
Oh, wow.
It's a non-pharmaceutical way to manage the disease.
So it's like a high-tech alternative to medication or surgery.
Exactly.
That's incredible.
And another big breakthrough in Parkinson's research is the validation of alpha-synuclein as the biomarker for the disease. Researchers have developed a test to detect it in spinal fluid, which could lead to earlier diagnosis and potentially more effective treatments. Absolutely.
And lastly, let's touch on ALS, also known as amyotrophic lateral sclerosis. It's a devastating disease that affects nerve cells in the brain and spinal cord, leading to muscle weakness and paralysis.
Right.
It's a disease with a very grim prognosis. Are there any new treatments on the horizon for ALS?
There have actually been 2 FDA approvals in recent years for drugs that can slow the progression of ALS, Relyvrio in 2022, and tofersen, also known as Qalsody, in 2023.
Okay.
While these drugs don't cure ALS, they can extend the quality of life for people living with the disease.
That's definitely a step in the right direction.
Okay.
What other research is happening in the field of ALS?
Well, there's a lot of genetic research going on. To try to understand the root causes of the disease, researchers recently discovered how mutations in the NEK1 gene contribute to ALS, which could lead to new therapeutic strategies in the future.
It's incredible to hear about all the cutting-edge research happening across so many different areas of science.
It is.
What are your kind of overall impressions of all these emerging trends?
I think it's a remarkably exciting time to be following science. We're seeing these incredible breakthroughs across so many different fields, from artificial intelligence to green chemistry to biomaterials to space exploration to medicine to energy. It's clear that science is advancing the potential benefits for humanity are immense.
It's really inspiring to see so much innovation and creativity being applied to tackling the world's biggest challenges.
It is, and it really underscores the fact that science isn't just about cold, hard facts. It's about human ingenuity, collaboration, and the pursuit of a better future for everyone.
Well said. Well, on that note, I think it's time to wrap up this part of our deep dive.
Sounds good.
We'll be back soon with more.
Thanks for joining us.
In the meantime, stay curious, stay informed, and keep those questions coming. One thing that's really struck me as we've been talking about all these science trends is how interconnected everything is. Like, it's not just these separate fields anymore.
Right.
It's like we're seeing this convergence where breakthroughs in one area are influencing and driving progress in others.
Like you take AI, for example. It's not just computer science anymore. It's being applied to everything from drug discovery to materials design, even space exploration.
Exactly. And that cross-pollination of ideas is what's leading to some really groundbreaking stuff. We're seeing it in green chemistry too, where those principles of sustainability are being applied to everything. From the plastics we use to the batteries that power our devices.
Yeah, it's like we're moving toward a more holistic approach to science, recognizing that everything is connected.
Right.
And I think that perspective is going to be really essential if we're going to address those really complex challenges that we're facing today, like climate change.
It really feels like we're entering a new era of science, one that's really focused on collaboration between different fields and solving real-world problems.
I think you're right. It gives me a lot of hope for the future, knowing that there are all these brilliant minds out there working to make a real difference.
I completely agree. It's easy to get kind of bogged down by all the challenges. But when you look at the progress being made in science, it's hard not to feel a sense of awe.
It's inspiring.
It's really inspiring.
There's such beauty in the natural world, and science gives us a chance to not only appreciate that beauty, but to understand how it all works.
And to use that knowledge to make life better for everyone. It's such a powerful tool for creating a more sustainable, equitable, just world.
Couldn't have said it better myself.
Well, on that note, I think it's time to wrap up our deep dive into this exciting world of emerging science trends. We've covered a lot today, from artificial intelligence and green chemistry to biomaterials and space exploration. We talked about CRISPR, the incredible advances in cancer treatment, and the global effort to find cleaner sources of energy. We even delved into the promising research being done on neurodegenerative diseases like Alzheimer's, Parkinson's, and ALS.
It's been a pleasure sharing these advancements with you.
So as we sign off, remember, science is for everyone. Stay curious, keep learning, and never stop exploring the wonders of our universe.
And until next time, keep those brain cells firing.